Recording. So welcome back for the welcome back for the second presentation. We're going to talk about file formats. So these are different file formats for storing data, in essence. So when dealing with data, you will have to decide how to store and also transfer or communicate data. So often you want to transform some data and then ingest it in another system. It depends on the requirements of your data pipeline, which solution you use. So there are different file formats, different ways to structure data, and we will go over these different ways and discuss their properties. At the end of the lecture, you should know the most common data formats used and also be able to decide which format is appropriate for which use case. So data models is the first part of this lecture. Here I included a reference, so it's based on chapter 2 in the reference book of Martin Kleppmann, on the chapter Data Models and Query Languages. Maybe it's worth mentioning, so in the book they go into much more detail than I go into the slides. So it's not important that you understand all the details of the book, but if you're really interested in the topic, I would suggest reading it. The second part of the lecture is on file formats. So we will talk about comma-separated files, CSV, XML, JSON, and also on file formats that are not human readable, such as protobuf and Parquet. So data models. The first data model we will discuss is the relational model. So a relational model, you have two examples below. For instance, the student's comma-separated file, and this is really the raw file content, consists of 3 columns. So you have the name, the last name, and the enrollment numbers. Jos Vermeulen, Anne van Damme, and so on. So you have one file like this, and so every file represents a single table, and a table is just consists of rows, and each row has the same number of columns. So that's basically, in essence, the relational model, and you can store it in CSV formats. The other example is grades. Here you have a column about the enrollment number, the grade, the course, the subject where the grade is assigned to, and the time. So these are simple examples of tables. Each row contains a primitive value, can be a string, an integer, a decimal number, or a floating point number, and a date. There are 2 types of tables. So you have entities. So entities are typically persons, groups, and maybe a list of organization and their properties, or in general, I would say objects. It can also be bank transfers, messages, really objects, things. Those are entities. And then another type of table is relations. For example, a student, maybe you have a table with all the students, maybe you have a table with all the courses and their properties, and then you have a relation, which student is enrolled in which course. So those are relations between entities, and often they are part of, has many, linked to. So these types of semantics. And each table can be saved to a comma-separated values file, like you see here. So here we actually don't use a comma, but what is it called, a semicolon or something. That's the file format. So here is another example about with a social network. So if I wanted to create my own Facebook, I could start with this relational model, and you see 3 entities. So these are highlighted in red, user with all their properties. So the user email, first name, last name, and age. Groups. So here are two groups. Republicans. I just invented some sample data. The U Antwerpen group and also the administrator of the group. And then below you have the messages. So for example, I created the message "Hello World" in 2018, and then created a new social network schema. So that's my message. And then Peter Sely created the message database forever. So that's also an entity because it's kind of thing. And then you have the relations. So you see all these tables are linked together. So the message creator, it's linked to the user table using the user email column. So if you want to create a message and you want to link that, you want to have the first name of the user who created that message, you should go to the users table, and there you have the first and the last name, or the other way around. If you want to know the messages of Len Veremans, you go to the message table, and then you select all messages which have Len Veremans as the creator. So this is how a relational model works. And then you have the blue tables, with the blue outline, member, friends, and likes. So for example, in my social network example, I have friends. So my friends are Ton Kalders and Peter Sely, and Ton Kalders is also friends with Koen Wouters, and so on. So here, the friends table, it's a relation between two users. And you have user 1 and user 2, and then you have a date on which is a date on which they became friends. For example, by clicking the Add Friends button or something. Another relation is member. So you have your different groups, and then the member table stores a relation between user and group. So Len Veremans is part of the U Antwerpen group. And then finally, the third relation is likes. So if I create a message here, then you can see which users liked my message. And so that's an example, and we'll use that example for the exercises. So what are the strengths of a relational model? Well, it's very structured. You have all these different tables, and for each table, you specify which are the columns in that table. So it's a structured format, which is an advantage. It also allows schema checking. So that means for every table and for each row, you know what's inside. You know each column, you know also the type of the column. So for instance, the user, if I want to have a table with users, I create this little schema where I say a user has an email address, first name, last name, and age. So email is the first column. It has to be a string, so a sequence of characters, and it's not null. So if I write that in a schema like here, not null, that means it cannot be empty. Then it's followed with another column, first name string, last name string, age an integer. So also mean if you're gonna add a record to your file and you check it, and in age you write a string and not just a number, then it will complain with age has to be a number. So that's also an advantage. The relational model is actually a natural model. So it's also a very old type of model. A relational model was introduced in the 70s. And at that time, applications were transaction processing, batch processing, for example, banking applications where you have to manage all the financial transactions, airline reservations, stock management, invoices. So these are the kinds of application where you really would prefer a natural model. It's also the main topic in week 5 on relational databases. That's where it's a natural model. And also, if you store data in a relational model, it allows a lot of flexibility when you want to retrieve information using queries. You can also ask what are all the members of a certain group, get message from all my friends, things like that. It's really easy to do with a relational model. So what are the weaknesses of the relational model? Well, first of all, the schema is static. So you specify what are the tables, what are the properties of each table, but often you want to have more flexibility. You want to, I don't know, add new properties every day, add new tables. So you can add new tables and columns in using a relational model, but it always has to be specified in advance. And also you want to say you specify the same structure for every row. So that's a weakness for some applications. Also, to combine data from different tables, you have to do joins. So joins, it's a key concept here. And whenever you combine data from two tables, for instance, I'm just going back here. So let's say I want not only the messages from every user, but also the first and the last name for every message creator. Then I have to join with the users table and get the first and last name from over there. So that would be a query where you need to join. So here I have an example. If I want to retrieve Len Veermans with age 39, which is in the users table, and also the group, which is in the member table, and also the content of the message, I have to combine three different tables, namely user, message, and member. So this is an example query in SQL, and we will go back into details of SQLs in week 5, but it's kind of complex. So joins, they're nice because you can do a lot with them, but they're a necessary evil. Okay, and then that's in very short a relational model. Then the second type of data model is a document-oriented model. So a document-oriented model, it's an alternative to the relational model. So the main properties there are it consists of keys and documents. So that means you have a unique key, and every key has associated with it one document. So what is a document? It's basically a tree, and it contains primitive values, but also nested entities and also relations. And a document can be stored and transformed using either JSON or XML. So here's an example. So it's the same application, but this time instead of storing all the different attributes of my of Len Veermans in my social network use case, I store everything in one document. So all the information about Len Veermans in the social network example is stored in one document. So I have the first name, Len, last name, Veermans, my age, which group I am member of. So not all the groups, but only the groups I am a member of, the administrator of that group, my friends, and also the first, last name, and daytime when we become friends is also stored here, and also my messages. So that's a very nice way or alternative way to store data. So instead of having these different rows in different tables with the same columns, we now have one document. So this notation is called JSON. It's also the same notation you would actually use in Python. So in Python, you would express this with dictionaries, and then you have a key and a value, and the value can be a primitive value such as Len Veermans or age, or in the case of members, the value is again a dictionary where you have the group, which is a simple property or a primitive string, Antwerpen, but then you have that administrator, and that's again a dictionary. So you can combine dictionaries within dictionaries, also a list of dictionaries, and then you have JSON. So what are the strengths of the document-oriented model? Well, it's also a structured way to represent information. So an example of an unstructured way to store information is just a Word document, where a Word document, it's just a bunch of data, but you cannot easily extract information using a query. And so it doesn't have structure. If you just have a web page on LinkedIn, it's not easy to extract my name or something. So structure means really encoding all the columns in a structured way. Oh, sorry. It's flexible. So what I mean is, with this document, it's easy to add new properties. So if I do not only want to store the age, but also my date of birth, I can just add a new line, a new property, date of birth, and add my date. So you can pretty much add anything you want at any time. However, you have to be careful, because if you add or remove some property, the application that uses this data, that loads this data, does make assumption. So it's in the book they call it a schema on reads. And so you have to be careful not to change your data formats all the time. But still, you have a lot of flexibility. So that's definitely a strength of the document-oriented model. The performance is also good since no joins are necessary. If you have all the data you want in one document, you just retrieve that document and you have everything. So that's good. And it's also a natural model when the data is tree structured. So one use case is text documents. So you have a section, a title. In that section, you have paragraphs. The first paragraph has 5 sentences. First sentence consists of 10 words. That kind of structure, so that's really like a tree, it's very good represented using a document-oriented model. So that's also why it got its name, where the name comes from. You have to be careful, however, with intra-document relations. So that's a disadvantage. I go on to the next slide. So it makes queries less flexible. If you have with the document-oriented model, you assume that most of or all the information that you want is within one user. If you want data over multiple users, such as all the members of a certain group, that gets less efficient with the document-oriented model. So what are the weaknesses? You have no static schema checking. So you're not sure, like in the relational model, if all the fields you expect are there. For example, you might forgot in some documents to have a first name, and then the application on reading that document will maybe complain or not work. So you don't have a way to statically check if all data you expect is there. And also you have a little bit less flexibility concerning queries than the relational model. And that's especially the case if you need to combine data from multiple documents. So if you want to have all members of a group, you should go go over all user documents, and for each user document, get a group membership out of that, and then aggregate all that information. So that's a little bit harder to do than in the relational model. And then the final model, so we had a relational model, document-oriented model, and now the graph model. So the graph model consists of nodes and edges. And a node is actually one instance of an entity. So for example, a user, and it has a unique ID. So a node is like an entity in the relational model, but it's not a table, it's just one instance of an entity. And then an edge is a relation between two nodes, and it also has a unique ID. And both edges and nodes have properties, where each property is also a dictionary, but with only primitive values. So here's an example. So you have the node user 101, that's the unique ID. You have some properties, first name, last name, age. Then you have another node, group 5. 5 is a unique ID with the property U Antwerpen. And then you have an edge between that instance of a user and that instance of a group, and that's the relation member. So that also has a unique ID, and that specifies the membership that the user is in. User 101 is in group 5, and so on. So this is a small example for illustration. So what are the strengths of the graph-oriented model? It's structured, also structured file format. It's flexible, so the schema can easily change. So between any two nodes, you can add properties, or it's extremely flexible actually. It's also a natural model for some application and domains, for social networks, but also think of road networks, where you have all the roads and each cross point, each road is maybe a node, or each cross point is maybe a node, and all the roads are edges. So that's a very natural model there. Also, it's interesting when the number of joins is variable. So for example, suppose you have all the roads and cities of Belgium in one graph model, then you can easily compute the shortest path between two cities. And then you get a list of all the edges you have to follow to the next node, which is another city, and then another edge or road to another city. And so you can compute the shortest path between any two cities if that data is in the graph model. Also in a social network, you can have your friends, or your friends of friends, or your friends of friends of friends, things like that, that can easily be done if you have your data in a graph-oriented model. So what are the weaknesses? Well, again, it's flexible, but it's like good and bad. So flexible also means no static schema checking. It's used in domains where everything is connected to everything. That's not really a weakness. I'm not sure, it's not really correct here, but also another weakness is the graph-oriented model. They're more academic, so they're used less in the industry, where a relational model or a document-oriented model are far more common. So it's more in the research area, or more maybe in a machine learning context that it's used. So that's a weakness. So in summary, each model is widely used for different purposes. There's no one-size-fits-all solution. And what data model you are going to use really depends on the domain. So that's the structure of the data, the type of applications. Also, I made like 3 different data models, but in practice they are mixed. So for example, the relational model is used in relational databases, but relational databases also support columns where you don't have just a string or a date, but a JSON block. So in practice, these systems are mixed. And then 4th point is that unstructured data, so I mean media files, can be image, video, audio files, also raw text documents, indexes that you might use in search and searching. In search application, you often have indexes. These are examples of unstructured data. And for unstructured data, we can also have a mix. Like, for example, you can have an application where you have a bunch of images, and then you can store the file name. You can store a link to the file name in a relational model and have some metadata, like who created the image, or when the image was created, stuff like that. And you store that in a relational model and then have a link to the file name. So that's often how it works. Okay, and then we'll go on the file format. So the data models was more conceptually. Now we're gonna talk about how it's stored. So we have 3 file formats in text, and then we have 2 formats in binary notation. So the first one is CSV. So it's a plain text format. I showed you the example before. Here's a small example below. So basically, you represent a single table from the relational data model. Each new line is a record. The first line is the header, so it has the names of the column of every column. The values are separated by either a comma, but you can choose it, so it can also be a tab or a semicolon. And if you have a comma in your data field, in your column, you can escape it by surrounding it with quotation marks. So it's a very simple format. It's used very commonly for batch processing, for exporting a large amount of data. It's also easy to partition. For example, you have sales data, then you can create a CSV file for every month. Then if you have billions of rows, you can split them every month. Then every month you might have millions of rows or thousands of rows. It does take a lot of space to store it, so it's not efficient to store it in text format, but you can also compress it using zip, for instance. So that's a common usage pattern. To open a CSV file, we can use pandas. Pandas is a library. We'll use it a lot for in the lab sessions. And to load a CSV file in Python, you need these two lines. So first you import pandas, so that's importing the library. As PD, it's often then you can write pandas pd.read CSV instead of pandas.read CSV, and then you just have the function read CSV file name. And here you see an example in Google Colab. So if I read a file here and I display the first 100 records, I get these screenshots. So it's very easy to open it with pandas. Then the next format is JSON. So I already shown some examples. So JSON stands for JavaScript object notation. It's almost the same syntax as you just described dictionaries in Python or in JavaScript. And it represents a single tree in the document-oriented model. So this is the example I showed before. I'm not going to go over it again. I think it's pretty obvious what this represents. So you have the curly brackets to denote the start and end of each dictionary. You have quotation marks for each key in your dictionary. So first name, last name, age, member, friends, and messages are the keys in the top level dictionaries. And then you have the values, which are here primitive strings. So again, you need a quotation mark, or a number you can just write without quotation marks. And then member is a special case. Here it's nested. So again, we have the curly brackets. And then we have within the member dictionary, again, two keys, group and admin. And then within admin, we have another dictionary with keys, first name and last name. So you should be able to write that yourself after some practice. It's very, very easy to describe data structures in this format. So yeah, the format, I already explained it. You can store primitive types, so integers, decimals, or floating point decimals. You can have a composite array. So it's based on two composite types. So either dictionaries, where you have curly brackets and then key value 1, key value 2 separated by commas, or you have arrays, and then you have straight brackets. So then you have a list of values, and that represents an ordered collection of values. And you can nest them arbitrarily, so a dictionary within a dictionary, then you have an array, and then stuff like that. So it's a common format for sharing data between different computers communicating with each other. And so actually, when you have two systems and they share data between each other, they send messages between each other, like give me information about user, and then the system returns a JSON document with everything of the user, things like that. So it's a very common format for sharing small messages between different computers. also used for configuration for application. And yeah, typically a single JSON document is small, so you will never have millions of attributes in a single JSON document. You can do that, but it's not it's not typically done that way. But you can have a database, a NoSQL database, such as MongoDB, and there you store millions of smaller documents, and you give each document a unique ID. So that's a common way to store a lot of JSON documents. So to open it, again, it's only 2 lines in Python. This time you need the JSON library, and then you call json.loads, and then you provide your JSON data as a string, and that will return a dictionary. So I've shown here another example in Google Colab. So that's something you will practice with in the lab session. And once the data is loaded, it's just a dictionary, and you can go loop over the dictionary and get all the different columns out of the tree. Okay, and then the second format, the third format we will introduce is XML. And I have here on the left, you see the JSON example, and on the right, you see the same data, but stored as XML. And actually, you can see the structure in JSON and XML, it's actually the same. They're both trees with nested trees where you store all the properties. The only difference is the syntax. So we're not going to talk too much about XML, because JSON and XML are just 2 ways, 2 encodings to store the same type of document-oriented models. So in XML, you have tags like user, and then the end tag it's with a little it's with a little bar here, user, and so also first name you encode it in this way. So instead of having a quoted string and then double point and then len, you have it in a tag. That's what it call it, a tag. But it's the same way to, it's the same principle. It's just a different way to store data in a document-oriented model. So XML stands for Extensible Markup Language. You represent a single tree of data in the document-oriented model. So you have the basic structure with tags, and they always must close. So every tag you open, at the end of the content of that tag, you close it again. You can choose the text. The text can contain anything, so you choose it yourself. So here I have the text user, first name, age, member, group, but you can invent for any scenario, you can invent your own text. It's also possible to have attributes of a text, so that's just a different way of writing information. So you have within the tag, within the brackets, you can have a key equals value kind of notation. So what is the usages of XML? Like JSON, it's a very common format for sharing data between 2 systems. So for example, a client and a server, they can communicate data in XML format. 2 applications or services can share data in XML formats. So XML or JSON are the top 2 types of data formatting for sharing data. Also, you have XHTML, so every web page uses HTML or XHTML, which is a type of XML. And it's also used a lot when configuring application or services. So XML is not only a data format, but it's also a language. With XML, you can do a lot more than JSON in that respect. So you can define your own elements and attributes, but you can also have a schema. So it's also possible to write a schema, and then you can check if all your tags are correct. So for example, I can create a schema where I say the root element of the document must be user, then it must be followed by first name, last name, age, and so on. And then if you add a new tag and it doesn't match the schema, then you can create an alert or something. So that's possible with XML. There's also a query language, XPath. So with XPath, you can write queries for an XML document, such as give me all friends of user Len, things like that, or give me the first name of all friends of user of that document. So that's something you can do with XPath. And there's also even a programming language, XSLT, and you can use that to transform the structure of XML documents or filter XML documents. You can do that with XSLT. But we're not going to talk about those two any further in the course, but realize that they exist. Here's an example how you can open an XML document in Python. So first you have to, again, import the XML library. So in this case, it's XML E3. And then you can open a document. So you parse the document. And once you do that, all the content of the file, the text file, country data XML, is loaded into memory. And then the document is like a tree. So you can get the root of the tree, and then you can print a tag. So in this case, it's data. And then you can traverse the tree. So you can say for each child in root. So that means all the data elements one level below the root elements. And in this case, these are countries. You can display the tag, and in this case it has an attribute, and you can print it. So these are two examples of extracting data from XML. So that concludes the text data format. So as I said before, these are used very often in the real world. So you also have a number of application programmer interfaces to get JSON data from websites. So Twitter is one example. So normally you go to the website of Twitter and then you get it in this representation, so visual representation for users with layout, so that it looks nice. But you can also get the same information from Twitter in JSON with 1 or 2 lines of programming, and then you can get all tweets of a certain user or all tweets of a certain period, and do something with it in a programming environment. Also for financial, there's a lot of financial data you can extract using, you can get in JSON formats. So here's some Python code, and then you get stock trades things directly from the web, and then load them in JSON and play with it in Python. Also for getting the current weather, there are APIs. So there are a lot of online websites. If you have their address, you can go to them from Python and extract all kinds of information in JSON format. So that's nice. Okay, then the last part of this presentation is on compressed file formats. Okay, so another 5 slides, and then I'm finished with the presentations. So first, let's talk a little bit about what is encoding and decoding. And I have a reference here to chapter 4 in the Clipman reference book. So usually in data, you have at least 2 different representation. And one is a representation in memory. So in memory, data is kept in objects, in structures, in lists, arrays, trees, and so on. Also specific to each programming language. So if you load data in memory in Python or in Java, for instance, it's a little bit different. But in memory, these data structures are optimized for efficient access and manipulation with the CPU. So that's one representation. The other representation, if you want to write the data to a file or send it over a network, and then you have to encode all this information in a sequence of bytes. So whenever you store something on disk or whenever you transmit something over the network, it's in essence, it's one array of bytes. So a JSON document is an example of this. And of course, this is different than the data structure in memory. So whenever we need to load data in memory for processing, or we have processed some data and we want to save it, we need to translate between these two representations. And that's what's called encoding or decoding. Encoding is also sometimes called serialization, or just writing data, and the reverse process is loading data, decoding data, parsing data, or deserialization data. So these are all synonyms, actually. So we're going to briefly talk about lossless compression formats. So like JSON and CSV files, they are all uncompressed types of formats, but it's important that you know that you can compress these data without loss of information. This is in contrast to lossy compressions. In images like JPEG, you save the original image in JPEG format, but you lose some data. It looks almost the same as the original image, but if you would really zoom in, you would see that the data is not, the information, there's some loss in the signal. So then, especially for images, the advantage is that it takes way less storage or space. So that's important for images on the web, because you want to load them quickly and not wait 10 seconds before a full 5 megabit image is downloaded. But for data, you often want compression without loss of information. So that takes less storage and also less bandwidth when transferred over the network. So compression formats are zip. Zip is the most important one. So with zip, you have any file or a series of files, and you save them as one zip file, and it takes up far less storage. You also have tar and gzip. So these are, it's like zip, but for on the Linux system. So we will also use Linux. Most of you probably use Windows or maybe Mac, but Linux is used a lot when having software on servers. So we will also learn a little bit about Linux. And with tar and gzip, you can also compress files. So technically with tar, you combine several files into one file, and gzip then compresses this file. Zip and rar. What's the difference? Well, there are two different ways to compress the data. Rar, yeah, I didn't think about it. Rar is another way to also another algorithm to also compress data, but it's also without loss of information. So you can also use rar if you want. Other two algorithms are bzip2 and 7zip. So here the difference with zip is they have a higher compression ratio, but they're a little bit slower to compress and uncompress. So you have to make a trade-off there. You can use bzip for a large file, and it will and the result will be even less. You will even use less storage as zip, but it's slower than zip. So that's a trade-off you have to make. With rar and zip, I'm not sure. I think rar and zip have about the same compression ratio. Actually, I'm not certain about that. I should have to look it up. Then we go to the binary formats. So CSV, JSON, and XML, they are less efficient to store large amounts of data. For instance, I have this example here, user name Martin, favorite numbers, and interest here in JSON. And if I store that in a file, it's 81 bytes. So for each character, you need 1 byte. And so a byte, that means 8 bits. So the way you compute it is 8 bits. That's 2 to the power of 8 number of different options. So that's 265 options. So if you have only characters and you use an encoding scheme such as ASCII, you map each character to one integer between 0 and 265. So that's how you would encode this. So if I encode this example, it's 81 bytes. And so what's the problem with that? For instance, if you have a large number, like 200 million, if you store that just in text, you store really a string of characters, and each character requires 1 byte. But actually, for storing numbers, you can use binary notation. And then if you have 4 bytes, you can store any positive number as long as it's smaller than 2 to the power 32, using a binary representation. And so here you would store, for 200 million, that's 9 characters, so you would use 9 bytes, while you only need 4, actually. And also property names such as username and favorite number in our example, they also consist of a string of characters, so you're going to store a byte for each character. But you could also say in advance, no, username is code 001 in binary, favorite number is 010, and then you only need 3 bits. If you have 8 possible different keys, keys, you can use 3 bits instead of 8 or 15 bytes for encoding the property names. So you can do it more efficiently with the binary formats. And then you have protocol buffers, which was original proposed by Google in 2001, and they have a binary format. So the idea is you have a schema, and you see it here. For the message, you have username, favorite number, and interests. And interest is a repeated string, so it's an array of string. Favorite number, it's an int, in this case with 46 bits. And you specify that schema, and with that schema, you can encode a message in a more efficient binary representation. And the same message in JSON would be only 33 bytes in protobuf. So that's already half the space required for storage and communication. So that's interesting. And the way you do it is you create your schema in text, and then you can generate codes, and you can do that in C++, Java, Python, any programming language. You generate a code using that schema, and then you can read and write files in that binary notation. And it will take less time to store, less space to store, but also it will be faster to read and write. So that's better for larger files. And then also you have Apache Parquet, that's the second binary format. So Apache Parquet, it's an open source file format by Apache. So Apache, they have a lot of different projects. They're all high quality and open source. So they're free to use. And they have this format, and also with libraries to read and write files in Parquet file in Java, C++, and Python. So the main difference with Apache Parquet is it's a column-oriented format. And like in CSV, you store every row by row, and every row of data is in a new file. But you can also store the data for each column. So you have all the usernames in one array, and then all the first names in one array, and then all the last name in one array, and then all the ages in one array, and store it in a pivoted way. And the advantage is with column-oriented format that if you then use encoding in binary format and also compression, such as run length encoding and using bitmaps, that you get a very nice compression. And it's also used often in analytics cases or data warehouses. And so that's the main topic of week 6 on NoSQL databases. So I have an example here. So here you have a nice, let's call it analytic example. So here you have a table, you have the dates, maybe a product that was bought, the code of a product that was bought, the code in which store it was bought, if it was a promotion, yes or no, code to the customer or null if it's not available, how many products were bought, and what's the net price and the discount price. So that's like a sales table. And for analytics, it's interesting because you can, for example, compute the total number of certain products sold, or which stores sell the most products, or which customers sell the most products. You can do a lot of analytics with that. And if you look at it from a column perspective, so in column-oriented storage, you would just have a sequence of all the values in each column. But you can already see, like for the date, there's a lot of repetition here. And so if you see a lot of repetition, that means it will also be compressed more efficiently if you store it one column using columns. Okay, so when to use what? So which file format are you going to use? So again, there's no one-size-fits-all solution. Every format has its own advantages and disadvantages. So when dealing with a large amount of data, it's best to use either a binary format such as Apache Parquet or Protobuf, or use compression. So you can also use CSV and JSON, but then compress it with zip. When transferring small amounts of data between systems or between web services, you can use either JSON or XML. And if you know in advance that you will mostly perform specific queries, you can select a format that's optimized for that kind of specific operation. So column-oriented queries, for example, if often you have a large data set, but you're only interested in one column or 2 or 3 columns, then Apache Parquet makes a lot of sense since it's in a column-oriented format. Also important is partitioning and replication of data. So often in practice, it's easy to partition or split the data. For example, if you have data of an entire year, maybe you can split it on a monthly, weekly, or daily basis. And then if you want to retrieve some data from the last week, you don't want a single file which has all data the past year. And it makes more sense to split the file, and split the data sets in files where you store all data for each week or month. And then that's more efficient that way. And so that's very easy to do. And that's also how it's done in practice. If you have a large amount of data collected over time, often they're partitioned according to time. Also, replication of data is important. So you can have a copy of the same data sets near each customer location for lower latency, or you can keep several backups of your data files on several servers to ensure that the data is never lost. So these are also important aspects of working with data. Okay, so this concludes this presentation. So I'm going to stop the recording now. I still have 50 minutes, and I wanted to use those 50 minutes to do an interactive tutorial. But we don't have a lot of time over, but Stine will also, in the lab session this afternoon, will go over the different Python things you need to know. So I'm gonna stop sharing now for one moment. So stop sharing, stop